Production and differentiation of cells to make somites is based on two different hormone gradients. Cells in the transition zone release FGF and Wind, which forms a gradient from posterior to anterior as the node moves posteriorly. Cells in the completed somites are stationary and release retinoic acid, which forms a gradient as the node moves away from them. These two gradients overlap to produce a continuous variation from 100% FGF and Wind, through a mix of these and retinoic acid, to 100% retinoic acid. As cells are produced in the transition zone, the influence of FGF and Wind makes them migratory mesenchymal cells. FGF also activates the clock mechanism and genes for Notch, HERI1, and EphA4 cycle, shown here by the changing color of the cell. When the FGF concentration drops below a threshold, the cycling stops. This threshold is called the determination wavefront. As cells pass this point, they enter the area of 100% retinoic acid and they transform from migratory mesenchymal cells to stationary stromal cells of the somites.
The clock mechanism for somite differentiation is based on feedback inhibition. FGF from the node causes the expression of Wind. Wind induces Notch, which induces HERI1, which in turn induces EphA1. EphA1 can cause somite formation. However, when Wind induces Notch, it also induces axon, and Notch induces lunatic fringe. These are negative feedback modulators that shut off Wind and Notch, respectively. These negative feedback mechanisms turn off the cell's ability to form somites. If the cell is in an area that has FGF, the cycle will repeat. Past the determination wavefront, the cells reach an area of no FGF, and EphA1 stays high, causing the cells to differentiate into somites.
Here you can see that as the node moves posteriorly, the gradient moves with it. The point at which the cells see only retinoic acid becomes the differentiation wavefront. Beyond this point, these cells undergo mesenchymal to stromal transition and become retinoic acid releasing somites.